Hey guys, this is the last video I'm going to have you guys watch. This assignment, as you saw in Classroom, is what you will be working on today in class for C period, and then on Friday in class for C period, or if you're in E period, you're working on it today and Friday as well. Okay. I just wanted to go through some examples on this. I know that long division problems take a long time because there are so many steps, which is why I wanted to give you guys the two class periods. However, like you saw in Classroom, for both C and E period, this is due by the end of class on Friday. It's not something that you're going to finish over the weekend. The two periods is more than enough time to complete 20 problems. Okay, that's like 10 problems per period. I know they take a long time, but they certainly don't take you or should not take you over 2 hours of class time to complete. Okay. So if you are C period and you're working on this on Wednesday, you don't have any homework that you need to submit to me by Friday, but by the end of class on Friday, you need to have this finished. Same thing for E period. If you're working on this on Thursday, you don't need to submit it to me by the beginning of class on Friday. You need to be submitting it to by the end. So if you're not getting any work done in class, you better make sure that you're finishing up as much as you can to submit it on Friday. Okay, everything is submitted by the end of class on Friday because then you have just a short worksheet for homework over the weekend. If you get it all done by the beginning class on Friday, then you have that whole class period to work on your homework, and then you don't have to worry about the weekend. Okay, but just know that this packet is due. It has to be submitted on Google Classroom again by the end of the class period on Friday. No late exceptions because I will be posting the answer key by the end of the day. Okay, so the first thing that I want to go over with you is I want to go over some examples. On numbers 1 through 6, if you notice, everything that you're dividing by is one term. It's a monomial, which means you don't have to really apply the properties of long division. If you look back at the notes that we had taken on Tuesday, with these types of problems, you're just taking everything that's in your first parentheses and you're putting it over that number. So if you look at, say, number 1, if I am taking this entire polynomial and I'm dividing it by 10n cubed, I could split it up. I could split it up to put 5n to the 6th over 10n cubed. And then I'm going to take this addition. I'm going to take 4n to the 5th over 10n cubed. And I'm taking this addition and putting 40n to the 4th over 10n cubed. Okay, again, because it's a monomial, because it didn't involve addition or subtraction, I'm able to do this. So from here, I'm applying my exponent rules that we learned, and I'm just simplifying. With our whole numbers, the 5 and the 10 are coefficients here. Those are both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. And then I have n to the 6th over n cubed. Again, we said we subtract the exponents there. We would get 3, and that n cubed would be up top. Now, you can put 1n cubed up top, or if you wanted to keep it as just n cubed over 2, that's fine as well. You don't necessarily have to keep that 1, but if you want to, you can. Okay, so that's this term simplified. Then I'm moving on to the next one. 4 and 10 are both divisible by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. And again, with these exponents, I'm going to subtract. 5 minus 3 is 2. There's more n's up top, so n squared stays up top. So that's this term simplified. And now with this last one, 40 divided by 10, right? 40 and 10 are both divisible by 10. 40 divided by 10 is 4. 10 divided by 10 is 1. And then I subtract my exponents. I get n to the 4th over n cubed. That would give me n to the 1st. There's more n's up top, so you can put the n up top if you wanted to. Again, you can put your exponent of 1. But again, since I have that placeholder of 1 in the denominator of this fraction, I don't actually have to put that there. Right? I could just leave it as plus 4n or plus 4n to the 1st, or even if you wanted to keep that 4n over 1, that's fine as well. But this would end up being your final answer. Okay? You're going to apply the same steps on, again, 1 through 6. Notice on number 2, you don't have any variable that you're dividing by. So really, the only thing that you have to pay attention to on number 2 is your coefficients. So if I set up 5k cubed over 4 plus 12k squared over 4 plus 4k over 4, right? Again, I'm not worried about the k's. I can't simplify this first one, right? 5 and 4 are not divisible by the same thing, so I'm keeping that as 5, oops, sorry, I messed up, 5k cubed over 4, because I can't simplify it. There's no k's, and these aren't divisible. I can simplify the 12k squared over 4 because 12 and 4 are both divisible by the same numbers. 12 divided by 4 is 3, and I still have that k squared. 4 divided by 4 is 1, so again, you can keep the fraction with that placeholder, but you don't have to. And then the last one, 4k over 4, those are both divisible by 4. You can see that they're going to end up canceling, right? So you'll just get plus 1k or plus k. So that's how you would approach number 2. The other problems, the other 4 in this top section on numbers 1 through 6, again, they follow the same rules. Sometimes you might get something like this where you can see you have a little bit of a remainder. They're not going to look perfect, right? They might be a mix of fractions and then numbers that aren't fractions, something like this. It's okay. Okay, so on numbers 1 through 6, this is the approach that we're taking because we're only ever dividing by one term, by those monomials. The rest of this packet on 7 through 20, that's when you do have to apply the long division. Okay? If I could make a recommendation here, I would say you could probably fit numbers 1 through 6 right on this paper, but I highly recommend that you do your long division problem, 7 through 20, do that in your notebook or do that on a separate piece of paper. You can see with the long division, it can get really large, it can get really long, and when I did this worksheet, I did it all on a separate piece of paper because I really could not fit the problems underneath them. Okay, so when you get to these problems, this is where the problems I would say, do it on a separate piece of paper to make your life easier. Okay, just scanning through these problems. They're all pretty standard long division problems. Again, I did some examples in that video yesterday with the long division problems. But let's jump ahead and let's look at longer problems like number 15. So these problems on the back that are a bit more complicated. I'm going to zoom in and try to give myself as much space as possible. No, that's too much. Okay. From here, okay, again, your long polynomial, the first one, always goes underneath your division house. You're going to have 5n to the 5th plus 15n to the 4th plus 10n cubed minus 65n squared plus 75n minus 38. And all of that is being divided by what comes second, the 5n minus 5. Okay, you can see that we, in the previous problems and even on the worksheet from yesterday, I think the most terms that I had given you that you needed to divide was 4. And it wasn't anything crazy. It was still a long process, but there was only 4 terms. You can see I'm giving you 6 now. So these are going to be even longer. There's going to be even more steps, which means there's even more opportunity to make little errors. So I want you guys to be really careful with these problems. Take your time. It's okay if it takes you a little bit longer to solve these problems. As I said, you guys have basically over 2 hours between the 2 class periods that you're getting to do 20 problems. And I've already done, this will be 3. I'm going to do probably a couple more after this one. So I'm already going to have done a couple with you guys. Okay? So my first step, I'm looking at 5n. I need to figure out what does 5n have to multiply by to get 5n to the 4th. Now I already have the 5, so I'm not worried about a coefficient. But to get from n to n to the 4th, I need to multiply it by 3 more n's. Sorry, this is 5n to the 5th. I'm already starting off kind of shaky here. My bad. Okay. So I need to say 5n times what will give me 5n to the 5th. And then again, I'm sorry. So to get from n to n to the 5th, I need to multiply it by 4 more n's, by n to the 4th. Okay? 5n times n to the fourth gives me 5n to the fifth. Most important step is to remember to make that negative. Now you can take negative 5 times n to the fourth. That'll give you negative 5n to the fourth. But again, the most important step is that you make that negative. So these cancel. Adding these together, 15n to the fourth plus 5n to the fourth gives me 20n to the fourth. And I'm carrying down that plus sign and 10n cubed. Okay? Next step, I'm taking 5n. 5n times what has to equal 20n to the fourth. You can do 20 divided by 5, or you can say, 5 times 4 gives you 20. And to get from n to the fourth, you'd have to multiply by 3 more n's. Again, remember, you're going to add those exponents. So the next one, I'm going to multiply by 4n to the third, and it's positive, so I'm keeping that plus sign. So 5n times 4n to the third is 20n to the fourth. Again, most important step is we make it negative. Negative 5 times 4n to the third is negative 20n to the third. But again, most important step is that we make it positive. We take the different sign. So these cancel out. I'm left with 30n cubed. And then I'm carrying down the next term. So I'm going to just keep going. I'm going to keep carrying these numbers down. You can see I'm almost already kind of losing space here. So this is why I said do it in your notebook. Okay. Next question we ask ourselves, 5n times what equals 30n cubed? Again, you can do 30 divided by 5, or if you know 5 times 6, that'll give you 30. To get n to the third, you'd have to multiply it by 2 more n's. So this is what goes on top of the house. We would have, again, it's positive, so I'd make it 6n squared. And then again, 5n times 6n squared gives me 30n cubed, but we have to make it negative. And negative 5 times 6n squared will give me negative 30n squared, but again, we have to make it positive. That's going to give me negative 35n squared. And notice every time with these numbers that I end up having that I have to multiply 5n by, they're always divisible by 5. If they weren't, that was your clue that you had made an error. Okay, so I have negative 35n squared. I'm carrying down the next term, which is the 75n. Okay, I'm going to start kind of going sideways. But my next question to myself, I'll put it over here, is 5n times what equals negative 35n squared? Right, you can do negative 35 divided by 5, or you can say 5 times negative 7 is equal to negative 35. And to get from n to n squared, I'd have to multiply it by an extra n. So it's negative, I'm going to put minus 7n on top of my house here. So 5n times negative 7n is negative 35n, but again, n squared, but again, we have to make it positive. Negative 5 times negative 7n is positive 35n, but if it's positive, we have to make it negative over here. So you can see these cancel. 75 minus 35 is 40, so I have 40n, and I'm going to bring down this negative 38. So the next question, our last step here, is 5n has to multiply by what to get 40n? And again, you can divide 40 by 5, or 5 times 8 will give me 40. And I don't need to multiply n by anything extra because there's already an n here. So I'm going to multiply, I'm going to put plus 8 because it's positive. 8 times 5n, or 5n times 8 is 40n. I'm going to make it negative here. And negative 5 times 8 is negative 40, but I have to change it to positive. So these cancel. Negative 38 plus 40 is positive 2. There's no other number here, right? Because I'd already brought that 38 here. There's no other number here to bring down. So this is where I stop, and I see that this is my remainder. So my final answer, if I can find a space to sort it right at here, my final answer is everything that was up top on my house. So n to the fourth plus 4n cubed plus 6n squared minus 7n plus 8. And then again, you can't forget about your remainder, right? We had a remainder of 2. It was positive, so I'm going to put addition. And remember that remainder always goes over what you are dividing by. So I have 5n minus 5. So because there were so many terms to start with in this beginning polynomial, it was an extra long problem because there were so many extra steps that we had to have taken. Okay? You don't need to show me this 5n times what equals 5n to the 5th, or 5n times what equals 20n to the 4th. I don't need to see this as part of your work because a lot of you could probably do it in your head. If it helps you, certainly write it down on your paper, but I don't necessarily need to see it. What I do need to see on all of these long division problems is this entire long process right here. So there's no way that you guys can show me that you got this answer without giving me these entire long division problems. Okay? So you can't get credit for anything that just has an answer on it. I need this entire piece. There's no way around that right now. Okay? So just something to keep in mind. Another problem that I want to talk to you guys about, and I'm just going to erase sort of up here so I can have some extra room. Another problem I want to talk to you guys about is number 16, because number 16 is a little bit of a special problem. First off, we know and we've seen on all of our worksheets and all of our examples that the polynomial that we're dividing is always counting down with the exponents. It starts with the largest exponent down to the smallest exponent. That's not the case on number 16. So before I even go to divide this, I want to make sure that I'm writing it in the correct order so that the largest exponent goes first and then it counts down. So on 16, we know that this goes underneath the little division house. The first term I'm going to write in here is the largest exponent, which is positive 3x to the 5th. I'm going to cross that out so I know I've already used it. The next term has to have an exponent of 4 because we're counting down. So this next one is negative 26x to the 4th. I'm going to cross that out because I know I've used that. Next term has to have x cubed, so I'm going to write that as 32x cubed. And I'm crossing it out so I know I used it. The 17x squared comes next. I'm crossing it out because I know I used it. And then I have 14x. Again, it's negative because there is that minus sign in front of it. And then the last one would be negative 9 minus 9. Okay? So, before I can ever set this up to divide, I have to make sure that I am dividing it in the correct order with biggest exponent counting down to the smallest exponent. And again, as a reminder, if there is a term that you are missing, say I didn't have negative 26x to the 4th and I just jumped 3x to the 5th plus 32x to the 3rd, I'd have to put a placeholder there. Okay, that's super important. We have to remember that if we don't have that term with the exponent, we're putting a placeholder in its spot so we're not forgetting about it. Okay, so if we look at the other, what we're dividing by, again, we want the x to come first and then the constant number. So rather than writing this as negative 5 plus 3x, I need to rearrange it to say 3x plus 5. That's the only way we can divide this problem, okay, if we end up having it set up in the correct order. Because now we can go through and we can follow the corresponding steps. Okay, I'm going to do it without those side pieces that I had written above. So 3x to get to 3x to the 5th, I wouldn't have to multiply my constant, but I would have to multiply by x to the 4th. 3x times x to the 4th gives me 3x to the 5th. But I changed the sign. 5 times x to the 4th is 5x to the 4th, but I change the sign. I make it negative. So I add these together. These cancel. Negative 26 minus 5 is negative 31x to the 4th. What did I do? I already goofed. What did I do? Where am I? No. What did I do?